What's going on, Playdate Community? Welcome back to another episode. My name is Franchovy, and in this series we're building your game. So, if you remember in the last episode, we were adding this new enemy type using some fancy inheritance stuff, such that we have this little jellyfish and we have a crab that's kind of stalking you and then stopping at a certain distance, safe distance. Only problem is that we've broken some of the collision functionality. So what we're going to do in this episode is actually going to take a look at some of the SDK's pretty nifty features regarding collision groups and collision group masks. So if you're all ready, let's jump right into it. If we take a look at the SDK and we look up collision groups, what we find is that there's some documentation about it. Wow, what a surprise. And there's two sets of functionality. There's the collision groups and then there's the group masks. So just to give you guys an overview, collision groups are basically like you give a sprite a group, and the groups are from number 1 to 32. And what this does is that under the hood, it will convert that into a group mask. And the mask will basically be a filter such that if there's one number that's the same as another number, they're going to overlap and that'll be a positive hit there. So let's say that you have a group 1 and then you have a group 1 and a group 3 in both. And then if they hit each other, it collides. However, if you have a group 1 and a group 3, they pass through each other. Now, we'll see how to get this working. It's relatively simple. There's two functions that we want to take a look at. There's the set groups, which is for the sprite's own groups. And then there's the set collides with groups, which is going to be the groups of whatever you want to collide with. So let's jump right into the code. The different groups that we have are the player. We've actually got the enemies as well. So all three enemies are more or less the same in terms of collisions. We've got bullets, and so bullets, because we want the crab to also shoot bullets, there's a question around how do we make that work. And then the last one would actually be the human that flies out of the ship when you get hurt. So let's create a new folder inside source called const, and this is where we're gonna put like our constants, sort of like enums, these kind of things. And I'm going to make one called collision. I'm going to make a file called collisiongroups.lua. And so the format that I use for any constants, especially enums, is like all caps with underscore. So collision underscore groups in all caps, const equals. Oh, sorry guys, we can't put const because it's a global variable. We're not putting local, so we can't use const there. Anyways, leave it as it is. Collision groups equals open brackets, and we're going to have 4 groups, as we said. We're going to have player equals 1. So in an enum, you always have to give a value, whether it's going to be a string or a number. And in this case, because we want to use it with the SDK, we need to give the number. Player equals 1. Enemies, IES equals 2. Then we're going to have bullet equals 3. And we're going to have human equals 4. So those are going to be our collision groups. Now let's not forget to import all of this stuff. We're going to create a new file at the base folder inside the source folder called const.lua. In here we're going to do import const/collision groups. And then inside main.lua we're also going to import const, and we can import it at the top, import const, because it doesn't depend on anything. All right, now that we have our collision groups, we can start using them. So inside player, we're going to go to player.init, and we're going to add a little comment above self::set collide rect, and we're going to do collision config. So here we're going to define both the group of the player and the groups that the player collides with. And so remember that we only care about the groups that we want the player to handle. So for example, a bullet, we don't care from the player's perspective because it's the bullet that's checking who it's going to collide with. So what we're going to do in this case is we're going to do self::set groups, open parentheses, and then we're going to pass in the collision groups dot player. Sorry, not human. Player. And then we're going to set the collides with groups. We're going to do self::set collides with groups open brackets. And here there's actually going to be two groups that we collide with, not the bullet, but we're going to have the collision groups dot enemies and the collision groups dot human. And you can tell that those are the groups that we need to collide with, because if you go to the update function and you go to the move and collisions portion, you're going to see that we have the jellyfish, which is technically supposed to be the enemies, and then we've got the human. So those are the two groups that we care about. Everything else we don't need to know. And then we've got the collision response as well, so we can leave that as part of the collision config. Nice. So let's go into the enemies and do the same thing. So we're going to add the comment collision config, set collide rect, which is perfect. We're going to add after that set groups, and we're going to do, so we don't need any brackets if there's just one. If you want to put more than one, you need to put brackets. We're going to do collision groups dot enemies, and then actually the enemy doesn't even do any collision checking with anyone, so we can leave it as is. We don't need to set the collides with groups. That will affect both crab and jellyfish, thankfully. We need to set the group for the humans as well. So let's open human.lua. Let's again add collision config, set collide rect, and then we're going to do self colon set groups, and we're going to do collision groups dot human. Now, if you want to, pause the video and do the last one, because you should know what it is. Hint, it's bullet. I'm going to open it, and we're going to go into bullet colon init. And we're going to, again, do collision config, adding a comment there. And then we're going to do self colon set groups. And I don't have autocomplete here. I'm just going to add the autocomplete really quickly. 3 dashes above class bullet, at class bullet colon playdate.graphics.sprite. So that's gonna, oh, and then we need to add an empty table. We're gonna do bullet equals empty table. So that's gonna help us with the autocomplete there. So if I go back and do set groups, then the bullet does have groups, collision bullet. And this one, unless you forgot, it has self colon set collides with groups. And then here, what group do we care about? So if the human is, if the player is shooting a bullet, then obviously we want to collide with the enemies. However, if somebody else is shooting the bullet, then maybe we need to be more clever about how that works. So we're going to put collision groups.enemies as the default for now. And then we're going to have to take a look at how we manage these things, because if we want somebody else to shoot a bullet, we're going to have to do it differently. All right, so already let's run the game and see whether all this stuff actually works as expected. So we run into the enemy, looks like that's working. We're able to pick up the player. If I shoot, then the bullets are not colliding with enemies the way I expected. So maybe we can take a quick look about what's happening there. Why aren't they colliding the way we expected to? All right, meanwhile, I'm totally stuck with these guys. First of all, let's check whether, let's go into the Playdate simulator menu and let's press show sprite collision rects, just to make sure that everything has a rect that's supposed to. Everything that's supposed to has a collision rect, and you can see that the bullets have a collision rect, so we don't know why it's happening. And in fact, I just scroll down and you can see the issue. If we're gonna add a breakpoint right here inside bullet colon update, and you can see that these collisions are happening here, and I go ahead and shoot a bullet, then what happens is that, first of all, we get a breakpoint hit, so the collision is actually happening. And then the funny thing is that we've added this whole check around whether the other class is an enemy or not. Now, the funny thing here is that we don't care if the other class is an enemy, because the bullet has hit its target. We've set the groups, collides with groups, and the bullet collided with the groups. So actually we can just remove this entire line here. Now I'm just going to add a safety check here where other, because we're no longer checking whether it's the enemy or not, we should not assume that it has this destroy function. What we're going to do is we're going to do if other dot destroy then, and then other colon destroy, and then end after that. And then you can call self colon destroy. And in fact, I'm gonna rename this destroy function so that it's more general and it doesn't interfere with some other destroy functions that we're using around the code base. So I'm gonna name it other.onBullet collision. So that now it's like specifically, if I get hit by a bullet, what do I do? And you'll see that this will come in useful very soon. So now that we've made that change, let's go to enemy and add a new function. So we have the destroy function that we were using previously. We're gonna add a new function called enemy::onBullet collision, open close brackets. And then here we're just gonna call self::destroy. So again, we're separating out this destroy functionality, which has more to do with like how do you remove the sprite, with the fact that a bullet is hitting that sprite. Because maybe multiple things can cause a destroy to happen, not just the bullet. Okay, and then that's pretty much it. Let's run again and see whether everything's working as expected. We're able to pass through the crab, so that's going to be something we need to take a look at. And then we're able to shoot bullets into the jellyfish and the crab as well, which is perfect. And of course, we're able to crash into that guy. We're able to shoot. Yeah, everything else works as expected. So let's make that last little change in the player. And let's go to where that collision check is checking for an enemy. Yes, so it's checking for a jellyfish. So what we're gonna do here, we're actually gonna interact with the collision group mask. So if we go back to the documentation, we've got set groups and we've got set collides with groups. However, the collision groups stops there, and there's no way to say get groups or get group value or has group or any of those things. Instead, we have to go down to the group masks in order to interact with that kind of functionality. So, and we've got here get group mask, as you can see. So what we're going to do is we're going to create an extension function on sprites. So we're going to open up sprites inside the extensions folder, and we're going to create a new function. It's going to be playdate.graphics.sprite dot so we're going to do colon, and we're going to say has groups, and we're going to do groups over here, and we're going to check whether the groups of that sprite contains the groups that we're passing in. And in fact, for simplicity, I'm just going to do has group for now. So it's going to check a single group. It's going to be, so we're going to do self::get group mask, open close brackets. So this is going to be the group mask. And then what I'm going to do is I'm actually going to have to convert the collision group, which is a number from 1 to 32, into a group mask. And so how do we do that? The format of a group mask basically works by having this 32-bit number. And the way it is that it's called a one-hot, I believe. It's one-hot encoding. And one-hot encoding means that any one of these numbers, if they're 1, then that represents that group, basically. So if you're, for example, part of group number 1, your encoding would be 00000, etc. 1. If you're part of group 2, then it would be 000, etc. 1 0, which is binary for 2. And then 3 would be 100, which is actually binary for 4. And then 4 would be 1000, which is actually binary for 8. So you see that we actually have to encode it using 2 to the power of whatever number we have. And there's a small caveat there where the groups that we're using starts with 1, but the group masks start with 0. So all of that information, what you need to type is self::get group mask, and then we're going to do an operator to mix it. But first, let's put in this conversion. We're going to do group -1 inside of parentheses. So group -1 inside of parentheses to the power of 2. And so that's going to be raising to the power of 2. So if you're a group 1, then your value is going to be 1. If you're a group, because 2 to the power of 0 is 1. And if group 2, you're going to have the value of 2 because 2 to the power of 1 is 2, etc. And then we need to basically find whatever operator works for putting the group mask and this thing, seeing if they have a match, and then returning whether they have a match or not. So the way you do that, and again, we're talking binary here, guys, really nerdy stuff. You don't speak binary, bro. All right, self colon get group mask, open close brackets, and we're going to put an ampersand symbol, and. So this is part of the bitwise operators, which is basically going to take both, and it's going to do an AND, similar to a Boolean AND, but it's going to do an AND on every single bit inside of those two numbers. And then we're going to check whether any of that is greater than 0. And so in order to do that, I'm just going to do not equal to 0. All right, guys, I'm just stopping here because this equation is wrong. I'm going to save you guys 1 minute. It's not to the power of 2, but it's actually 2 to the power of group minus 1. So reading the entire equation, it's return self colon get group mask, open close brackets, ampersand symbol, 2 to the power of, in brackets, group minus 1, close brackets, is not equal to 0. That's your equation. Anyways, you're welcome. See you in a second. So that's going to be your has group function. So that will save us a bit of trouble because now we can just check whether the sprite has a group or not. Hey, Panic, add this function in, please. Save our Playdate community some trouble. All right, so I'm gonna go back to player.lua, and over here, instead of doing this whole get meta table collision other equals jellyfish, actually, that's the one I care about, I'm gonna do, so here we're colliding with another. We have the collision.other as the sprite that we're colliding into, and so we need to check whether this other sprite is part of the enemies group. So we're gonna do, again, replacing that thing after the and before the then, we're gonna do collision.other, colon, has group, and then here we're gonna do collision groups dot enemies. And that's it. Now that we have that function, it's really nice and easy to check whether the group is there. And then we have it on touch enemy. And then for the human, we can leave it as it is. Like, it's not really a big deal. If you want, you know what, let's just be consistent. Let's just add that same thing. Collision.other has group, and then we'll change that group to human. I guess it doesn't make a big difference, but you know, might as well while we're at it. So we're gonna refresh the game, start again, and we need to check whether the human is able to, oh, I'm flying through everyone now. Uh-oh, what have I done wrong? All right, thanks, time travel Franchovy. So now that we've made that change, we can try running it again and see whether that works. So let's run into this crab. Okay, so we know that this one works. And why am I not using bug? Okay, and the crab also works. And I believe that the bullets should also collide as expected. All right, that's perfect. Guys, I did notice 2 small bits in the code. We're just gonna do a bit of housekeeping because there's 2 issues that we can run into, 2 potential crashes. And so I'm just going to fix those right now. So the first one is in player. And if we go to on death, then basically there needs to be this timer human lost. But if the timer human lost has been removed, then we end up with an issue there. So we're gonna add a check for if self.timer human lost, then, and then we wrap those 2 lines, self.timer human lost removed, self.timer human lost equals nil, because if we call remove and the timer is not there, then we're gonna have an issue. And just for safety, we're also gonna do that on touch human. If self.timer human lost, then, and then those 2 lines, and then we'll have an end afterwards. All right, that's the housekeeping done with. Thank you guys so much for watching. In the next episode, we're gonna be adding the bullet from the crab, and we're gonna be adding animation states as well. Maybe in different episodes, we'll see. All right, guys, take care, have a good one, and I'll see you in the next one. Bye-bye.